Hello guys, welcome to our studies on matrices. Today our studies is on finding the determinant of 3 by 3 matrices using the minor and the cofactor magic. Now what we need to note is to know the terms to note and understand. And what are these terms? So these terms are the minor, the cofactor, and the determinant itself. If we want to be able to understand these particular problems or to understand the concept of the determinant of 3 by 3 matrix, these are the terms that we need to note and understand. Now let's understand the concept of minors. Now for each element in a 3 by 3 matrix, we can define minor as the determinant of 2 by 2 matrix formed by removing the rows and column of that element. So here the minor is denoted as capital M subscript Ij. The I denotes the rows and J denotes the columns to be removed. So here let's consider a 3 by 3 matrix below, and we have a 3 by 3 matrix of this particular nature, and here too this particular expression denotes the position of the entries of each of the 3 by 3 matrix that we have here. So when you look at the element 2, the entry 2, its position is the first row, the first column. Element negative 1, its position is the first row, second column. Element negative 6, its position is the third row, the second column. Element 3, its position is the second row, the third column. So if I want to find the minor of element 2, here it is being marked with a purple pen. So the minor of element 2 means that we need to find the determinant of the matrix left, the 2 by 2 matrix left, when you remove the first row and the first column. In this case, when you remove the first row and the first column, the 2 by 2 matrix left to find the determinant will be the minor, which will be the green elements here, -2, 3, -6, and 7. And the determinant means that we should multiply the first diagonal, also multiply the second diagonal, then subtract the results of the second diagonal from the first diagonal. So here -2 times 7 will be here, then -3 times -6 will also be here. Then -2 times 7 will be -14, then 3 times -6 will be -18, and negative will be positive, which at the end of it all, our minor answer will be -14 plus 18 equal to 4. Now, using the same standard or the same principle, we are going to consider the same 3 by 3 matrix with their entries. Then this time we want to find the minor of 3. Then what is the position of 3? This 3 here, the position of this 3 here is an element in the second row, the third column. And in this case, we are going to delete the elements of the second row. So we delete the element of the second row, then also delete the element of the third column. Here we delete the third column. So second row, third column has been removed, and the rest of the 2 by 2 matrix, the determinant of it becomes our minor. So here the minor will be 2 times -6 minus 4 times -1, or -1 times 4. Then at the end of it all, our minor answer, the determinant of this 2 by 2 matrix, will be -8. Let's move on and also consider another element, which is -6. We want to find the minor of -6. And what is the position of -6? It is in the third row, second column. It means that we are going to delete the third row and also delete the third column. All the elements there, we remove it. Then the rest of the 2 by 2 matrix left, we find the determinant of it, and it becomes our minor. So the minor will be the determinant of the 2 by 2 matrix left here, which is 2 minus 8, 0, 3. And the answer will be 6. So this is the understanding of minus when it comes to 3 by 3 matrix or square matrix. Now, let's come to another term, which is the cofactor. So the cofactor of an element Aij in a square matrix A is the sign of the minor. So the cofactor deals with the sign of the minor. And we understand the minor now. So the cofactor can be denoted as Cij. So as it is, the rows will be the I, the J will be the columns. So the general format of the cofactor is of the form -1 exponent I plus J, the row plus the column. So here, let's consider this 3 by 3 matrix in an element form, which each element have their respective position. So if I want to find the cofactor for the first element, which is in the first row and the first column, that is 1, 1, then what I need to do to know the cofactor is the I here will be 1, the J here will be 1. So 1 plus 1 is 2. So -1 exponent 2 will be a positive answer. So let's see this particular table. We have the element and their cofactor. So the first element here, which is position 1, 1, first row, first column, will be +1. So it means that its cofactor sign is plus, because the exponent will be an even number 2. Here, when you go to the next element in the row form, first row, second column, its cofactor sign will be negative. Why? Because the exponent here will be an odd number. So it repeats itself in all of them. So when it comes to the element position 2, 3, first, second row, third column, the exponent will be 2 plus 3, which is 5, which is odd number, and its cofactor will be negative, and so on. So in general, when you consider the entries of the 3 by 3 matrix, their respective cofactor will be plus, because when you sum 1 plus 1, the answer is 2, which is even, and the exponent, if -1 raised the power an even number, it will be positive. So here it is positive. 1 plus 2 is 3. It is odd, so it will be negative. 1 plus 3 is 4. It's even, so it will be positive. 2 plus 1 is odd. It will be negative. 2 plus 2 is 4. Even, it will be positive. 2 plus 3 is 5. Odd, it will be negative, and so on. 3 plus 3 is 6. Even, so it will be positive. So these are the respective sign for each of the entries when it comes to 3 by 3 matrices. So now, what are we going to do next to understand the determinant of 3 by 3 matrix? So generally, when we are given a matrix of this nature, which is 3 by 3, and we want to find the determinant, how do we do it? So the determinant denoted as det of A will be equal to, look at this particular format very well, and this will help you to understand the concept easily. First, I can use the first row to find my determinant. So if I want to use the first row to find the determinant, then the determinant will be elements of the first row, which is element A11, times its cofactor times its minor. So we need to understand it. So A11, its cofactor, its minor, multiply all of the results together, plus the element A12 times its cofactor times its minor. Then element A13 times the cofactor 13 times the minor 13. So this will give you the results of the determinant of 3 by 3 matrix. Or you can also consider the middle row, which is the second row. And the same process or the same scenario have to be used here. We have element A21 times its cofactor times its minor plus element A22 times its cofactor times its minor plus element A23 its cofactor times its minor. Or you can also use the third row to also find your determinant, element A31 its cofactor its minor, A32 its cofactor its minor. Multiply all the results together and that will give us the determinant of the matrix A. Now let's work on a practical example. We have to find the determinant of matrix A. So look at the element being denoted with a green pen. This time we are going to use the first rule to find our determinant. And what will be the first rule? So the first rule will be of 1, 3, negative 5. So determinant A will be equal to the first element, each cofactor, its minor. The next element in that rule, that's the first rule, its cofactor, its minor. Then the next element in that same rule, its cofactor, its minor. So here the element 1 is the first element, the cofactor is positive, then the minor will be the determinant of the 2 by 2 matrix left when you remove the row and the column, the first row and the first column. So we have 4, 6, negative 7, 9 plus the 3. The cofactor is negative, then the minor is negative 2, 6, 0, 9, the determinant of it. So remove the column and remove the row, negative 2, 6, 0, 9. Then repeat the same thing for the last element of the first row, which is negative 5. The cofactor is positive, then we have minus 2, 4, 0, negative 7. The determinant is the minor of the third element in the first row. So here the determinant will be equal to, so 1 times positive will be positive 1. Then you find the determinant of this matrix. Then 3 times negative will be negative 3, determinant of this matrix. Then negative 5 times positive will be negative 5, determinant of this matrix. And this will be 1. 4 times 9 is 36. 6 times minus 7 is 42. Then 36 minus 42. Then we have minus 3. This time this will be minus 18. 0 times 6 is 0, minus. Then minus 5. We repeat the same process. Minus 2 times minus 7, 14. 0 times 4, 0, minus. So here, when you simplify your result, 36 minus 36 will be 78. So 1 times 78, then our results will be written. Then we have minus 3, minus 8 times 0, minus 18. Then minus 5 times 4. Then at the end of it all, when you simplify this expression, the determinant will be 62. So that is how we find the determinant of 3 by 3 matrix. Now let's continue with the examples and also understand a very simple trick. On choosing the best row, if one row has multiple zeros, use it to reduce the number of calculations. So what we are saying is that look at this particular matrix which we are going to find the determinant. The second row is having multiple zeros. So to make our work easy, we can use the second row to find the determinant of this particular matrix, not to overstress ourselves using other rows, because we already have those entries in as elements in the second row. So here, what will be the solution? We are going to use the second row. So as such, the second row, the element will be A, that's the second row, the first column. We are going to use that element with its cofactor and its minor, the multiplication of this expression, plus the second element in the second row, that is 0, its cofactor, its minor, plus repeat the same process for this 0, the A23 its cofactor, and its minor. So here, the determinant will be 4, which is the element 4. Its cofactor is negative, that is 2 plus 1 is 3. And negative 1 exponent 3 will be negative. Then the determinant of the minor. How do we get the minor? Remove the column, remove the row, which will be left with -5, 2, -6, and 9. Repeat the same process for the 0, that is A22. So the cofactor is positive times the determinant of its minor, plus the 0 here, the cofactor is negative times its minor, that's the determinant of the 2 by 2 matrix left, when you remove the third row and the second column. So in this process, we are going to realize that 0 multiplying every expression here will be 0. 0 multiplying every expression here will be 0. That will make our work very easy. Then negative times 4 will be -4. Then negative 9 times 5 will be -45. And 6 times -6 will be -12. The negative between them, so negative will be positive. Then our results will be -4 minus 33 times -33, which will be 132. Because negative and negative is positive. So this is how we find the determinant of 3 by 3 matrix. Let's expand ourselves to understand an equational form of this particular 3 by 3 determinant. We should find the value of k. If the determinant of p is 13, we have to repeat the same process, which here 2 times its cofactor times its minor. We are using the second row to find the determinant because we have a 0 entry. So here we use the 0 here. The cofactor sign is positive times its minor. The -1, the cofactor sign is negative times its minor. When we do that, we are going to get -2, then 15 minus 6k. That's the determinant of this 2 by 2 matrix. This one will automatically be 0. Then the same thing happened to this expression. At the end of it, we are going to have -30 plus 12k. Because -2 times -6 will be 12k. Then the 0 plus 4k minus 5 equal to 13. So it means that we are going to make k the subject. So 16k minus 35 equal to 13. Then 16k equal to 13 plus 35. Then we get 16k equal to 48. So our k will be equal to 3. So that is how we solve this particular problem. So this studies is all about determinant of 3 by 3 matrix. So there is a section for you to try your hands on this particular activity. So find the determinant of this matrix and find the value of y when this particular matrix has no inverse. See you another time. Thank you.